Alright, welcome back to the vise project that we were working on earlier. So in the previous video we drafted and designed this base block. So in this video we are going to continue on with a couple of the components of the base block. Next thing we want to draft on this will be the jaw, the moving jaw. So we're going to start on that right now. So instead of starting an entire new drawing, we can instead create a new body. So in the body tabs right here, we have a drop down. Now that we have one body in here and we're going to start adding more, I'm going to start naming them. So I'm going to name this first one base, so we can keep track of what's going on. When we hover over them, they will highlight, help us keep track of that somewhat. Alright, so the first thing we're going to do is start a sketch. The next sketch is going to start on this face. Problem is when I click that face, now I have the other end of the vise in the way. So what I'm going to do is finish sketch. Obviously I didn't do anything, but that sketch still shows up in our work tree right here. I'm just going to delete that so we don't have that cluttering up our work tree. So in order to be able to see where we're working without this in the way, what we're going to do is go over here to inspect. In the drop down, we're going to do a sectional analysis. When we select that, it's going to let us choose a face. So we can choose any face on the part. We can even choose our starting faces. I'm going to choose this face right here, and I'm just going to drag this slider back. So this is going to allow us to split the part right at 3 inches. So that is halfway through it. I'm just going to drag it back. I'm not worried about any angles or anything like that, just because I want to be able to see what I'm doing. Hit OK. So now, when we look head onto this part, we can now see our work surface. This can be turned on and off now in our analysis tab. So in the drop down, we can choose which sectionals we want to turn on and off, or we can just hit the eye up here to turn them all on and off. So we can turn that off and see our analysis, or our full part again. Turn the analysis back on, see what we're doing. Alright, so we're going to come up here to create sketch, select that plane. I'm going to get my line tool, and I am going to start sketching out the plane here. So this is going to auto snap to the existing features. I am going to change one thing though. So this one line right here, I'm going to take the snipping tool and cut that off because I don't actually want it to end right at the corner. I'm going to let it be parallel. See how it kind of snaps to parallel? Right there, but we're going to come down, square, up. Obviously this line isn't square, so we can come to our strengths, horizontal, vertical. Hit the constraint on that, it's square again. Now, the reason I have this hanging over is because I don't want an exact match between the base and the rubbing components. If I made this exactly the same, it would actually bind up inside. I want some clearance. So what I'm going to do is now bring that to 0.5. The reason I'm going to 0.5 and, whoops, Z. Control Z is your friend. All right, so if we remember the original we made to actually 510, we can inspect that by hitting the measure tab and measuring that, and right here it's going to show us we actually made it to 510 thousandths. So that means if I bring this to 0.5, I'm going to have 10 thousandths of total clearance on my part, which is what I want. So obviously it's not center. To make it center, we're going to use constraints again. I'm going to use the equal constraint on this one and this one. By forcing these to be equal, it's going to force it in the center. Obviously it's a little cockeyed because this is not square, horizontal, vertical. Hit that again, and we are in business. So I also don't want this completely parallel with the bottom. Again, to avoid those binding issues, I want another 10 thousandths of clearance there. So what I am going to do is I can take a measurement, inspect, from here to here. And I will get a distance of 1.118. Also, I can just select zoom in and select just the edge line. I might have to shift my view to see it, but I can select this plane to this plane. Whoops, inspect that plane, that plane. And I will get a distance, 0.5. That's what I was looking for. So sometimes you can't get the exact planes you're looking for if you stay looking head on. Now that I've got that, I've got my 0.5 distance. So I know how far that is. So I can click here to go face on again. And now take a measurement, sketch dimension, from this line down to this line. And I'm going to go 0.510, 510 thousandths. Again, this is going to give me 10 thousandths of slack here. And that's what I'm looking for. All right, so we've got our sketch fully defined, no blue lines. I'm going to hit E to extrude, select those areas. What's highlighted is what will be extruded. Now, I want this to be 1 inch wide, so I can drag out to 1 inch, and it's going to automatically want to join. We no longer want to join because we're making a separate part. So we're going to do new body. So now we see a line appeared here because this is now creating an entirely new piece. All right, so we're going to select that. Now we have a second body right here, body 2. We're going to call this jaw. So now we have our vise jaw. And if we turn our analysis off, we can see how it's going to sit inside of that groove. That's going to keep any kind of twisting moment from taking the jaws out of alignment, keeping our force aligned. The only problem now is it can lift directly up, out. So we need to capture that inside. So this groove right here keeps the twisting moment down. And now this groove right here, we can add a plate to keep the bending or the dropping movement or movement along the Z axis out. So I'm going to create another sketch, select this face, and I'm going to do some circles. Circle here, select distances, 0.25, 0.25, 0.25. All right, so that's given us our location on this axis, this axis, this axis, this axis. Now to dimension these holes. So what size are we going to do? So we're going to pull up our McMaster-Carr again, figure out what kind of screws we're going to be using. Socket head cap screws, alloy steel. I'm going to go with a 1032 on this, or a 1024, because that will be the right size. So I'll drop down to 1024. So for this, 3/8 fully threaded course will be perfect for our application. It will give us our length, thread, decimal equivalent, all that fancy information. So this is one of the pieces of information we need. Decimal equivalent information. And let's see. We will go back towards taps. Let's see, 1024 tap. 1024 drill bit size 0.1495. All right, back here 0.1495. 0.95. All right, so we've got that done. And now I'm going to go to equals. Make those equal. And now I can hit E to extrude again. I'm going to be extruding up. We will go, I'm actually going to type in negative 0.375. So we're going to drill 3/8 depth in, cut, that's what we want. Okay, so that will give us our tap drill size for the holes we're going to be doing. Now I'm going to create another sketch because that is where we'll bolt into, but we need a plate to hold it in place. So I'm going to create another sketch on this face. Just going to go with a square or a 2-point rectangle this time. And I'm going to go with 0.875 and 0.875. How does that look? Again, I'm just kind of making this up as I go, so it's really a visual thing at this point. I need clearance, so I need to stay under 1 inch. That looks a little too small, so I'm going to go 0.95. 0.95. All right, that looks better. So now I need to make some holes. I'm going to wait until that circle appears. That means I am concentric with that circle. Put a circle here and a circle here. Now when we looked at those screws earlier, we saw that their diameter was 0.190, so 190 thousandths. That means for clearance, we're looking at somewhere around 0.2 to 205 is going to give us good clearance over that screw pitch, or the outer diameter of that screw. So I'm going to go equal, equal. So now both those holes are 250 thousandths. Now I need the square to be centered on those. I could just measure out distances and that would work. A quicker and easier way is to hit line. And now here in the options, I'm going to hit this right here, which is construction. I can click that, or I can hit X on the keyboard, which is the hotkey. So with the construction line situated, I'm going to go corner to corner on this. And then I'm going to go center to center on these two holes. The center one is white because it is fully defined. This one is kind of a brownish orangey color because it is not defined. So now under my constraints, I'm going to come to midpoint. So the midpoint is going to select the midpoint of this line, and now I'll select the midpoint of this line. They will snap to each other. Now they are constrained together, and that is going to put us square on. All right, so that looks good. I'm going to hit E to extrude. I'm going to select those 3 sections, and I'm going to come down 0.125. Obviously, it's going to want to do a join. We don't want to join because this will be a new body, because this will be a separate plate that will be screwed on in order to hold the jaw in place. So new body, okay. So now we have a new body. Whoops. There we go. New body right here that when screwed on will hold this jaw in place from just dropping out and keep it in this groove that we've established. All right, that looks good. We're going to call that a, we'll call it keeper plate. All right, so we got our keeper plate in place. That should have clearance. So we made this deep enough we have clearance over our socket head cap screws when they get screwed in. And that is looking good. Alrighty, so on to the next piece. So for the next piece, oh no, sorry, my bad. This is not finished. So there is some more modification we need to do to this in order for it to be even attachable to our lead screw. Completely almost forgot about that. So again, I'm going to create a sketch on this face. Once I create a sketch on this face, I'm not going to be able to see it because all this is going to be in the way. Our analysis is still here from last time, so we're going to click that analysis and turn it back on so we can see what we're doing. Now I'm going to create a sketch on this face. So we're going to need a hole in the center of this, which matches up with the hole from the lead screw. So I'm going to put a circle. The lead screw is going to be a 3/8 Acme thread, so the outer diameter will be 3/8. We need to go slightly bigger than that. So I'm going to go 0.4 or 400 thousandths, enter. And then I need this to be in the same plane on the z-axis as the previous hole, which fortunately I was keeping common size, so 0.5. And it will also be centered here, which will be 1 inch. So that is our first hole. We also need 4 more threaded holes along this face in order to bolt a plate in that will keep the rod contained. So I'm just going to eyeball 4 holes. There are multiple ways to do this. I could do 1 hole and then do a rectangular pattern. I find if I'm only doing 4 holes that it is not any quicker to use a rectangular pattern. If I'm going to 6 holes, then I'll start using the pattern feature. But for now, 4 holes. I'm going to go back to my line feature. Again, X or hit construction. And then I'm going to chain these 3 together. By doing so, just in a C formation, I can now use the horizontal, vertical to make sure that they all stay in the same plane. Also, I'm going to use the equal constraint on all the holes because they will be the same size. So when I finally do say where it's going to be, they will all be in the same plane. All right, so now we're going to dimension these apart. 1.5 and 0.5. All right, so if we don't know where the constraint is missing, we can grab any of the blue lines, tan lines, and drag them, see what happens. And as we can see, it can move up, down. Also, this one is not defined, so it can move in and out because I only did 3 lines, not 4. So I'll add a 4th line in there and do a horizontal vertical constraint. Now they all move together. But I want them centered on this hole. So again, another line, another construction line. I'm going to move across, and I'm going to go to my constraints, midpoint constraint. So the midpoint of this line, centered on that one. Now those are all in place. Now I need to decide what size hole this is going to be. For the set screws on this one, they need to be much smaller. So I'm going to use instead of a 1024, a 640. So for the 640 tap, we're going to be using a 113 thousandths drill bit. All right, so click back over here. 0.113, 113 thousandths. All right, so that will be our setup. E to extrude. Select all our surfaces. And we're going to extrude back ½ inch seems a bit much. So let's see. 0.412. Oops, I forgot to put the negative. If you just type in a positive number, obviously it's going to go in the positive direction, not do a cut. So to change that, I can go back down here onto my workflow, right click, edit feature, and go in there and add the negative that I should have had there to begin with. And whoops, edit feature again. So I did go negative, and it is showing negative, but it's still showing join. So now I need to manually bring that down to cut. That's what I'm looking for. All right. So now we have our hole cut as well as our tapped holes, or what will be our tapped holes. That looks good. All right. So we can turn our analysis back off. We don't need that right now. So now we need our push rod that is going to go through that hole. Also, we need to create the plate that is going to back it. And I will create those two pieces in the next video, as this one's starting to run a little long. If you're interested, please follow along. Obviously, I'll post the next video. And forget all that like, subscribe, stupid BS that